Alright, so we are going to be kind of going into the trigonometry of right triangles. This follows along with a section in your book, 6.2. So there are some more examples in there if you want some practice. So your objectives for this lesson are going to be, you will understand and apply trig ratios to solve problems. You will be able to solve a right triangle. You will be able to solve problems involving angle of depression and or angle of elevation. So there may be occasions where you have to use both. And this one right here, this is probably going to be the most challenging part of this section. So just a quick note, you want to get confident in your knowledge of 30, 60, 90 triangles. So like what sine, cosine, tangent, not just 30, 60, 90, but the special ones, the 60, 30, 90, 30, 60, 90, 45, 45, 90. Know what sine, cosine, tangent are at least, and then you should be able to figure out the rest of these. If you need a little bit of practice, go back to some of your notes from last unit. Also, make sure you know the reciprocal functions. So, for example, that cosecant is the same as 1 over sine, so on and so forth. Alright, so let's start off with some real easy things. Let's find the six trig ratios of the figure. So given angle theta here, and we've got these three sides, find the 6 trig ratios. Okay, so sine, of course, this is the angle we're working with. So opposite over hypotenuse, root 7 over 4. Cosine, adjacent over hypotenuse, 3 over 4. And then tangent, opposite over adjacent. And then we have our cosecant, our secant, and our cotangent. So basically just reciprocal functions, and again, can't have radicals in the denominator. So we rationalize those. Alright, so now, that was just kind of a warm-up. Now we're going to get into solving a triangle. So now when you're asked to solve a triangle, you're basically being asked to determine all of the missing information. And this is by the time you're done with the problem. All three angle measures and all three sides should be known. So since they're right triangles, you're going to know at least one of the angles, probably another one, which is going to make finding that last angle really, really easy. So you're going to be using right triangle trig, and that's the common sense. That's knowing that there's 180 degrees in the triangle. If one angle is a right angle and you know one already, you should be able to do basic math to find the third. Alright, now sometimes all you have to do is recognize it's a special right triangle and fill it in. So like if, for example, it was already in like root 2 over 2 was the length of one side and the angle was 45 degrees. You wouldn't really have to do anything except fill in the different ratios. But trig is actually going to come in very handy here. So you can use ratios or you can use trig. I'm going to show you how to use trig because that's what I want you to get used to using. So let's solve this right triangle. Okay, so we know it's a 45, 45, 90 because we know it's a right triangle. We know that one angle is 45. So we know the other angle is 45 right off the bat. In a 45, 45, 90, both legs of the triangle are congruent. So we know the missing side is 16, which leaves us to just find the hypotenuse. Now, you could use the Pythagorean theorem, or you could use the 45, 45, 90 degree ratios since it's a special right triangle. But I would prefer that you get used to using some trig, and on an easy problem like this, that would probably be your best bet. Now you could use either sine or cosine. It doesn't matter. I chose cosine because we're trying to find the hypotenuse. So you want to use sine or cosine because the hypotenuse is part of those. So we know the angle measure is 45. So I did cosine of 45 equals 16, which is the adjacent side, over r, which is just what I named the hypotenuse. Alright, so cosine of 45 degrees is root 2 over 2, and that equals 16 over r. So all we have to do is solve for r, and when you do that, you're going to come up with r equals 16 root 2 for your answer for the hypotenuse, and now we know all three sides and all three angles. Easy peasy. Alright, so now, into the harder stuff. We've got angle of depression and angle of elevation. So there are some real-world applications for this. So when you ask when you're ever going to use it, if you ever thought about a career in navigation, surveying, astronomy, so on and so forth, those all use these types of things. Some important terminology for you to use because they're going to come up in the problem. So when they're talking about line of sight, they're talking about the line from the eye of the observer to the object. Okay, when they're talking about angle of elevation, they're talking about the angle between the line of sight and a horizontal line between the object and the observer. And this would be above the horizontal line. Angle of depression That's the angle between the line of sight and a horizontal line between the object and the observer, below the horizontal line. Now, if that's confusing, I have pictures. So, this is angle of elevation because here's the horizontal right here. Let me change the pen color. So we've got our horizontal right here and our line of sight. So she's looking like at the watering can falling over, whatever that is, paint can. Okay, so we've got the angle of elevation is above that horizontal line between her and the building. Okay. Now in this one, she's looking at the guy who was walking and the paint can fell on his head. So now this is below the horizontal line, so it's an angle of depression. So let's put this into practice. The angle of elevation to the top of the Empire State Building is 11 degrees. So angle of elevation. So we're talking about a horizontal. So a person's like right here. And we're talking about the top. Ooh, that's going to be a really weird Empire State Building. Okay, and then the top of the Empire State Building. Okay, there's the doors, windows, antennas. Alright, I know that's not a very good Empire State Building, but you get the idea. Alright, you know what? I'm just going to make it the Sears Tower. There we go. Problem solved. Bada bing, bada boom. Okay. So, from the ground, so we've got a distance of 1 mile from here, and an angle of elevation of 11 degrees. Now again, I like drawing these for the visual, just for me, so I can kind of see what I'm looking at. So I've got this right triangle here. I need to find the height of the Empire State Building, or in my case, the Willis Tower, which is not accurate, but whatever. Alright, so I'm going to use tangent because I want to find this over here. I want to find the height. Okay? Now, what am I given? I'm given the angle, so I'm going to use a trig function, and I'm given the adjacent to the angle, so I need something that has the adjacent and the opposite, which is tangent. So I use tangent of 11 degrees equals the opposite, which is what I'm trying to find, over the adjacent. Now again, I just want to find the opposite, the h. So I multiply both sides by 5280. By the way, that's how many feet are in a mile. Got that, feet in a mile, so that's where I got that number, because we said we were 1 mile from the base. So I just, in my calculator, you really can't do this without a calculator. So 5280 times, and I just hit tangent of 11. Make sure your calculator is in radians. You may get an answer. If it's not, it just won't be correct. Alright, so which should, if you've got your calculator, go ahead and see if it's in there. You should come up with that number, which would give you a height of about 1,026.33 feet. Alright, so now let's look at one with an angle of depression. So we've got a plane flying, so here, got our little plane. Okay, it's flying this way. And then we've got the Gateway Arch. So I think that kind of looks like that. It's an arch, right? Okay, in St. Louis, Missouri. And we're at an elevation of 35,000 feet. Alright, pilot would like to estimate her distance from the arch. So that would be this. Angle of depression is 22 degrees. So what I'm really looking at is this kind of right triangle. Alright, so which means that this side is going to be 35,000. Alright, so now we want to find the distance between the plane and the arch. So we're trying to find this right here. We could call that R if we wanted. Alright, and we know the altitude of the plane, so we know the opposite. So we're trying to find, we have the opposite, we're trying to find the hypotenuse, which is sine. So sine, opposite over hypotenuse, which I called R. So 35,000 over R equals sine of 22 degrees, which R equals 35,000 divided by the sine of 22 degrees, which when you plug it in your calculator comes up to about 93,431.35 feet. So that would be the answer to that. Now the second part, what is the distance between a point on the ground directly below the plane, so like right about here, and the arch? So we're trying to find this distance, which also happens to be that distance. Alright, so now that we know the hypotenuse, which we found up here, we can use cosine, because cosine is adjacent over hypotenuse. So I take that adjacent, which is what I'm trying to find, set it equal to cosine of 22 degrees, solve for b, which is what I decided to name this. and you come up with an answer of about 86,628.04 feet. So that would be angle of depression. Now occasionally you will be asked to do both. So we've got a water tower located 325 feet from a building. So we've got this water tower. Okay, 325 feet from a building. So here's our building over here. Alright, and an observer in a window, so we'll say the observer's here. So here's our horizontal line, they're looking at it. Notice that the angle of elevation to the tower is 39 degrees. Okay, that doesn't seem to be cooperating. Let's try this again. So the angle of elevation is 39 degrees. Angle of depression is 25 degrees to the base of the tower. So we want to find out how tall the tower is. Now, we know that the distance from here to here is 325. I am not writing very well. Sorry. 325. So I set it up. Now tangent, because we have our adjacent and we need the opposite of both. We have the adjacent of both and we need the opposite, because if you think about it, we've got two triangles that look like this. This line right here is 325. We're trying to find that, and we know that this is 39, and we know that this is 25. So without a picture, that's what we're looking at. So this would be like height 1 and height 2, or vice versa. So we go ahead, set it up, solve for A. Okay, that's going to give you about 263.18 feet. You do the same with the angle of depression. And I actually set it up wrong, so forget that that's 28. Let's say that that's 14. I don't know how I saw 14 for that. Alright, so tangent of 14. Same thing, same adjacent. And we get 81.03 feet, which when you add them together would give you the height of the water tower at 344.21 feet. Now, how high is the window? Well, our horizontal went straight across, and then so the height of the lower triangle, this side here, which was 81.03 feet, happens to be the same height as the window, so we're good there. Alright, so a little confusing on that last one. You have to use a little bit of both, but overall I think that this stuff isn't terribly hard. You'll have some practice with angle of elevation and angle of depression. You'll be pros at it. So that's all I have. There'll be another video coming up. Have a good one.